Okay, so for differentiating trigonometric functions, okay, we have different trigonometric functions: sine x, cosine x, tangent x, secant x, cosecant x, and cotangent x. We'll get the derivative on that later. Okay, so these are the trigonometric functions with their corresponding um, derivatives. So dx of sine x is cosine x, dx of cosine x is negative sine x, dx of tangent x is secant squared x, dx of cotangent x is negative cosecant squared x, and the dx of secant x is secant x tangent x. Lastly, dx of cosecant x is negative cosecant x cotangent x. We will use that for our examples here. Example number 1, we will differentiate f of x is equal to secant x plus 3 cosecant x. Now, here are the notes for the trigonometric functions with their corresponding derivative of their functions. Okay, so for the secant x, so since this is in a sum, um, according to the sum rule, we will just get the derivative of the individual derivatives of the function. So the secant x, so that's dx of secant x. According here in our table, dx of secant x is secant x tangent x. Plus the 3 cosecant x, we can see in constant here, so we will just separate that and we will use that later. So dx of cosecant x, according to our table, the cosecant x is equal to the negative cosecant x cotangent x. So 3 times the negative cosecant x times the cotangent x. So the answer is secant x, the f prime of x is equal to secant x tangent x minus 3 cosecant x cotangent x. Okay, so another example, the g of x is equal to x squared sine x minus 3x cosine x plus 5 sine x. So the g of x is this one. Okay, they are separated by minus and plus, so we will get the individual derivative of the function. But notice, the x squared is separated by the sine x as well. So these are two different functions. So we will use the product rule for this first part. The second part is the same. We have a constant multiple rule here, and then we have two different functions, which is the x and the cosine x. Again, we will use the product rule here, while here is a constant multiple rule. Okay, so let's start with the first one, the x squared sine x. Using the product rule, we will multiply the x squared times the derivative of the second function dx of sine x plus the second function sine x times the derivative of the first function dx of x squared. Next part is the 3x cosine x. 3 is a constant. We will just separate that yet. So 3 times now the x and the cosine x. We will use the product rule. So the first function x times the derivative of the second function dx of cosine x plus the cosine x, or the second function, times the derivative of the first function, which is x. And lastly, 5. So 5, according to constant multiple rule, times the derivative of the sine x. Okay, let's solve. Okay, x squared times the derivative of sine x, this is cosine x, plus the sine x and the derivative of x squared, according to power rule, that's 2x. Minus the constant here is 3 times x times the derivative of cosine x, according to our table, is negative sine x, and then plus the cosine x, and then derivative of x is 1 plus 5 times the derivative of sine x, again cosine x. Let's multiply. X squared times cosine x is x squared cosine x. Sine x times 2x, that's 2x sine x. Minus 3 times x times negative sine x, that's positive. 3x sine x. Negative 3 times cosine x times 1, that's negative 3 cosine x. And then plus 5 cosine x. Let's combine like terms, so we will just combine 2x sine x plus 3x sine x, that's 5x sine x, and then negative 3 cosine x plus 5 cosine x, that's 2 cosine x. So x squared cosine x plus 5x sine x plus 2 cosine x is the derivative of our given function. Remarks here: whenever Rule 7 is applied to problems where the trigonometric functions are viewed as functions of the angles, the unit measure must be in radians. Every trigonometric function is differentiable on its domain. In particular, the sine and cosine functions are everywhere differentiable.